Hello everyone. Today in this video I'm going to explain how to convert any number into binary so that our computer can understand that number easily. So imagine we have a number that is 13. Now I want to convert this number into binary. In binary format, any number can be stored in the form of 2 to the power. I mean to say, for example, I have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and so on, so more. Now, we have to just mention the result of this. For example, when I say 2 to the power of 0, what is the result of it? Of course, 1. And it is 2, 4, 8, 16, it is 32, and so on. So now, if we want to convert any number into binary form, we have to compare that particular number with the forms of this 2 to the power. For example, we have 2 to the power 0 as 1 and 2, 4, 8, 16, 32. We need to compare this particular number that is 13 with all of these numbers and we have to figure it out where it fits very well. So for example, if you want me to compare this number that is 13, I would start comparing this number 13 with 2 power 5 that is 32. So I just wanted to know whether 32 is greater than 13 or not. Of course, 32 is very, very greater than 13. So I would say 32 is greater than 13. So I would place this as 0. Okay. Now I would like to compare this number 13 with 2 to the power of 4. What if I can compare 13 with 16? Is it still greater than 13? Of course, 16 is still greater than 13. So I would place it as 0. Now I would like to move for the next number. So I would like to compare 13 with 2 to the power of 3, which is 8. Now I would want to know like whether 8 is greater than 13 or not. Of course not, right? 8 is less than 13. So here 8 is actually fitting very well in the number 13. So this time I would place 1 because here it fits very well. So I am actually placing it as 1. Now, after if we find out that it fits very well into any number, we have to subtract that number from the 13. For example, I would subtract 13. I would subtract 8 from 13. So together it gives me number 5. So now we have to compare the other numbers with this particular number, that is 5. We have to compare, now we have to compare 4 with the number 5. For example, if we compare 4 and 5, which is greater? So I would say still 4 is less than 5. So it fits very well. So I would place 1. Now, after placing it as 1, we have to do some subtraction here. That is, what is the subtraction here? So we have to subtract 4 from 5. Then we would get 1. Now we have to compare this number that is 1 with the other numbers that is 2 and 1. So we have to compare this 1 with 2. What I would say is 2 greater than 1? Of course, 2 is greater than 1. So this number 1 is not at all actually, so this number 2 is not actually fitting in 1. So I would place it as 0. Okay. Now if I place it as 0, then I would move to the next number that is 1 here. Here it is having 1 and here also I'm having 1. So this 1 is actually fitting very well into this number that is 1. So I would place, so I would just like to compare whether 1 is equal to 1. Of course, yes. Now I would place this position as 1 and I would subtract 1 minus 1 together gives me 0. Okay, now just rearrange all these numbers within the brackets and group them together. For example, I have 0, 0, 1, 1, 0, 1. So this has become my binary number for the number that is 13. How can I say this is the binary number for 13? Because if you just try to extract the powers of it, for example, what is the power for this 0? Nothing but if it is 0, we have to ignore it. So we just ignore it. So if this is the 0, then we have to ignore this thing. Okay. But here it is 1. So we should not ignore. We have to consider the power. What is the power? That is 2 power 3 here. In the sense, it is the value of 8. So we have to write the value of 8. Okay. Now what is the power for this particular one? That is 2 power 2. In the sense, we are getting the value of 4. So you can write 4. And if it is 0, we have to ignore. And if it is 1, we have to consider the power. So here we are having a 1. And what is the power of it? 2 power 0. Okay. In the sense, 1. So you can consider it as 1. You just add all these numbers like 8 plus 4 plus 1. Together gives you a number that is equal to this particular number. So this 13 is equal to this 13. So this is the perfect representation of any number in the form of binary. Got it? So this is the binary conversion for the number 13. Now I would like to show you the binary conversion for another number just to get a more clear understanding. Okay. So I would consider the number 10. So let's just write out all the powers of 2 here. First, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Just stop it right here because when you just write down its result, you'll get to know. 2 power 0 is 1, 2 power 1 is 2, 4, 8, and 16. Just stop it right here and just compare all these numbers with this particular number that is 10. If you compare 10 with 2 power 4, I just want to know whether 16 is greater than 10 or not. Yes, 16 is still greater than 10. So I would place this as 0 and I would like to move it to the next number. For example, I would want to compare 10 with the 2 power 3. What is the result of the 2 power 3? That is 8. So I would like to compare. If I just wanted to know whether 8 is greater than 10 or not. No, 8 is less than 10. So 8 is actually fitting very well within this 10. So I would place this number as 1. Now after placing, I would like to have a subtraction here. That is 10 minus 8. What is the value? That is 2 here. So I would like to compare all the next numbers with this particular value, that is 2 here. So I would like to compare whether 4 is less than 2 or not. No, 4 is still greater than 2. So I would say it is not fitting. So I would mention it as 0. And I would like to move to the next level, that is 2. So I just wanted to compare whether 2 is equal to 2 or not. Of course, 2 is equal to 2, right? So I would place this position as 1. Okay. So now, if you can just subtract this, for example, 2 minus 2 gives you 0. Right here, we have to stop because whenever you have got 0, then obviously you have to stop right here. Now you can just summarize all these, or you can just group it all together. For example, if I group it together, what is the value here? I would write it as 0. What is the next value? That is 1. What is the next value? That is 0. What is the next value? That is 1. And what are their corresponding powers? For example, if you write the power for this 0, what is the power of it? That is 16, right? So if it is 0, we should never consider. So you won't consider this. If it is 1, you have to write down the power of it. That is 8. So you have to write the power, that is 8. If it is 0, you are not going to consider it. And if it is 1, so you are not going to consider this 0. And if it is 1, you have to write down the power of it, that is 2. You write the power 2. And if you do addition, 8 plus 2, that is equal to 10. Together, it is actually getting matched with this particular number with our resultant number. So this way you can create any binary form of any number. So this way our computer understands very well where to store our number and how to actually understand a particular number that the user pass. So this is how you do it.